Welcome to day 7. We'll be talking about today product of the means versus product equals product of the extremes. Page 48 and 49 is your homework. You have 2 warm-up problems. Go ahead and pause the video, do the 2 warm-ups, and when it pops, when you hit play again, it'll pop up for you to put in your answers to the warm-up. All right, so notice AB matched with XY. So then the other one we had AC, that should match with, you should have either said either XZ or ZX. IS matches with OP. We've got OH, so that should either match with BI or IB, one of those two. Moving over to your homework. They told us the triangles we wanted similar. We had perpendicular lines implies right angles, and then right angles implies congruent angles. Make sure you're getting the ones congruent that are actually in the triangles, because there were also right angles here and here, but we didn't actually need. Then we have parallelogram implies opposite angles congruent to get A and C congruent, and then angle-angle similarity postulate to get our triangles similar. In number 2, they told us the 2 triangles we wanted similar, the left and right ones there. Start with your angle bisector implies 2 congruent angles to get the ones I labeled 1 and 2. If it's isosceles, if there's 2 congruent sides, we can say that ABC is isosceles. And then isosceles triangle implies 2 congruent base angles, giving us A and B congruent. Then we can use our angle-angle similarity postulate. In 3, we've got AB parallel to DC, so do your congruent alternate interior angles to get D and B congruent, A and C congruent. So that's the quickest way to do it. You could have just done one pair and then also done vertical angles if you wanted. But then we get our angle-angle similarity postulate. We have AEB is similar to triangle CED. And then our proportions, our reason would be similar triangles implies proportional sides. In 4, there's only 2 triangles in that picture, so it's pretty obvious which ones are trying to get similar. They told you C is a right angle, then do your perpendicular lines implies right angles to get angle 1 is right. Then you can do right angles implies congruent angles. They both share angle A, so we can do angle A is congruent by the reflexive property. That gives us the angle-angle similarity postulate. Triangle ADE is similar to triangle ABC. And then we'll do our similar triangles implies proportional sides. So for day 7, we're going to start on page 45, and we'll have one new reason that we will add on to our similar triangle proofs. So if you have a proportion, the product of the means is equal to the product of the extremes. So basically that means we can cross multiply. So if we have this proportion here, that means that B times C should be equal to A times D. Or if you have numbers here, 3 times 6 is 18, 2 times 9 is 18. Now the extremes are considered the one that was the smallest and largest, and the means are the ones that are in between. So that's what's meant by product of the means equals product of the extremes. The smallest and largest thing end up multiplying together, and those middle ones will. And that just automatically happens. This is our new reason that we will have. And we will notice in our proof statement sets of sides that are being multiplied. Well, essentially, it's the cross multiplying that occurs after you have your proportion set up in your similar triangles implies proportional side step. So our new step for today is one step beyond the similar triangles implies proportional sides. So if we go down to the bottom, we've got our first one here. Let's start out, we'll just do our statements and reasons and get our givens, and then we'll come up with a plan. So when we see this proof statement, we want to recognize, okay, this is just a similar triangles proof. So we're going to do our angle-angle similarity postulate. We'll do our similar triangles implies proportional sides. And then this proof step here will be our new thing, product of the means equals product of the extremes. So we've got 5 different triangles in our picture. So we have to identify which triangles we want to work with. So start with your first side, and we're going to go through till we find a side that's only in one triangle. So ER. ER is in triangle ERT, and that is it. Now, when I say in a triangle, that needs to be the entire side. Not part of the side, not more than a side of a triangle. That is the entire side of a triangle. So ER is only in one triangle, so that's great. So we need to look which of those 3 other sides is also in ERT, and that would be TE. So we know we've got ERT as one triangle. And then the other one is SD and DT, so we would want SDT. And they might not be matched in that order with the letters. We'll worry about that later on. But these are the 2 triangles that we're looking to get. So notice we already have some right angles. So let's go right away and we'll do right angles implies congruent angles. And we want to use the 3 letters that they gave us. So TE, angle TER is congruent to angle SDT. And we'll mark those in our picture with their boxes. Well, we've also got an isosceles triangle. So let's do isosceles triangle implies 2 congruent base angles. The angles that we want are angle R, that will help us in the red triangle, and then congruent to in the blue triangle. Can't number it because there's so much going on there. We just have to use 3 letters, so we'll call it angle DTS. So this angle here is congruent to that angle there. Well, we should be in good shape. We've got 2 sets of angles now. So we'll do our angle-angle similarity postulate. Our statement will be that our triangles are similar. So we'll maybe do RET for the first one is similar to triangle. R was our congruent base angle, so we'll do T in the other one. E was our right angle, so that matches with D. And then our third letter was S, so TDS. As we saw in the previous class's lesson, next comes our similar triangles, implies proportional sides. Now, we don't have that as our proof statement, so we've got to come up with what our proportion is. And what you do is you just make sure the sides that you want multiplied are diagonal from each other, so that when you do the cross multiplying that it does work out. So we're going to put ER here, and we'll put SD down there, because they need to be diagonal from each other, and then just put the other 2 diagonal from each other, DT and TE. Well, now our new step for today, our statement is just going to be what we want to prove. And our new reason for today is product of means equals product of extremes. And basically that is why we can cross multiply stuff. No, you cannot write cross multiply for the reason you have to write product of means equals product of extremes. And that's basically the new thing for today, that one extra step. So we'll be able to do a whole bunch of practice with similar triangle proofs, and then we'll practice that one new step as well in the rest of this video. So moving on to page 46. We'll start with our statements and reasons and givens. So let's see if we can go through and find which triangles we want to get similar. Because I count 1, 2, 3, 4, 5 different triangles in that picture. So let's start with AC. AC is definitely a side in the huge triangle, ACE, but it's also a triangle, a side in triangle ACB. So that doesn't narrow it down for us. So let's move to the next one. Let's go to BA. So BA is a side in BAC, but it's also a side in BAD. Okay, so we're not entirely certain off that one. So let's move to the next one. AD. AD is a side only in one triangle. It's only in ADB. So we know ADB has to be one of the triangles we're working with. AD, and which of the other three is a side in there? BA would be the other one. So that means our two remaining sides, AC and EA, must make up the other triangle. So AC and EA means we're working with the huge triangle. So EAC, and the letters might not be matched up right. We'll worry about that when we get to that step. So we had that BD and EC were parallel. So here and here. Well, if we extend our sides a little bit, it's a little bit easier to see, but still challenging. Those two that I just put a dot in are congruent, are corresponding angles, and they're congruent because we have parallel lines. So we're going to do parallel lines implies congruent corresponding angles. And we'll go ahead and we'll just number them 1 and 2 to make life easier. Well, notice when we trace the triangles, angle A got traced for both of them. So that will allow us to do a reflexive property. And we'll just have angle A is congruent to angle A. And we should be in good shape now to do our 3-step conclusion to similar triangle proofs. We've got 2 congruent angles, so we can do our angle, angle, similarity postulate. I'm going to name the first triangle ABD is similar to we said ABD, so that must match with ABC. After we say that they're similar, we always do next. Similar triangles implies proportional sides. Something new for today is we have to set up the proportion. Remember, we want the sides that are multiplying diagonal from each other. So I'm going to put AC here and BA there, so they're diagonal from each other. And then just make sure the other two are diagonal from each other. And then our new stuff for today, our statement is just what we want to prove. AC times BA is equal to AD times EA. And our reason is product of means equals product of extremes. Moving down to the bottom, number 3, take a minute, do your statements and reasons and given. So I count 8 different triangles in this picture. Based on our proof statement, we want to recognize, okay, that's just 2 steps after our similar triangle step. So we want to try and get 2 sets of angles, but we needed to identify which triangles we're looking for. So start with SR. SR is a side in SRT and SRJ. So multiple ones. Let's move on and see if we can find one that's only in one. PJ. TJ is a side in RJT and WJT. So let's move on. TW. TW is a side in TWJ and TWQ. Okay, let's move on. SJ. SJ is a side only in SRJ. So we were down to the end, but we found one. Okay, the only triangle that SJ is a side in is SRJ. So find of the other 3, which one is also in SRJ? That would be SR. Well, then the other 2 should make up the other triangle, TJ and TW. And those letters might not be matched up right, but we'll worry about that when we get to this step. They told us that RP, so this whole thing is parallel to that whole thing. Well, we've got some zigzags there. Let's call that angle 1 and angle 2. We could do a zigzag that way. And we could call this 3 and 4. We could do a zigzag going that way. So we'll do our parallel lines. Implies congruent, alternate, interior angles. And that'll be both angle 1 congruent to angle 2 and angle 3 congruent to angle 4. Well, already we got 2 sets of angles. Now, you could have just done 1 set and done vertical angles, but that's more work, so we'll do the 2 sets. So we're ready to do our 3 steps to finish off a similar triangle proof. We'll do angle, angle, similarity, postulate. Triangle, we'll go SRJ first. Is similar to triangle. S was the alternate interior that matched with T. R was the alternate interior that matched with W. and then J was the third letter. Automatically, next we do similar triangles, implies proportional sides. We have to set up the proportion, make sure the sides we want to multiply are diagonal from each other. So SR I'm going to put there, TJ will then have to go down there. And then just make sure the other two are diagonal from each other as well. And to finish off, our statement will just be what we want to prove. And our reason will be product of means. Equals product of extremes. Moving over to 47, go ahead, do your statements, reasons, and our givens. So we only have a few triangles there. We have 4 from what I can count. So let's see which ones we want to get similar. We know we've got to get similar triangles based on that proof statement. We know that's going to be 2 steps beyond the similar triangles. We start with TS. So TS is only in triangle TSZ. So another one that's in TSZ would be SZ. So that means our other 2 sides, QZ and WQ, have to make up the other ones. That would be that triangle. So QZW, and again, those might not be matched up correctly, but we'll figure it out when we get there. So we started with a parallelogram. In a parallelogram, we know opposite sides are parallel. So we're going to do parallelogram implies opposite sides parallel. We've got 2 sets of parallel, but the ones we want so we can do some zigzags are PS and QR. If you're unsure of which ones you want, just name them both. But we know we want PS and QR for our zigzags in this triangle, and we want those parallel. And then from there, our proof's going to be really similar to the one we just did. So we're going to do parallel lines, implies congruent, alternate, interior angles. So we could do a zigzag here. Let's call those 1 and 2. And we could do a zigzag here. Let's call those 3 and 4. So we'll have angle 1 congruent to angle 2, angle 3 congruent to angle 4. And now we can do our 3 steps to finish off a similar triangle proof, because we got 2 sets of angles. We'll do angle, angle, similarity postulate. And we'll name our triangle similar. We've got triangle QWZ. It's similar to triangle. Q was the blue angle that matched with S. W was the purple angle that matched with T. And then the Z's match up. After that, we automatically do similar triangles implies proportional sides. So TS and QZ have to be diagonal from each other, and then SZ and WQ have to be diagonal from each other. And to finish it off, we'll do our product of means. Equals product of extremes. And our statement is just what we wanted to prove. That TS times QZ is equal to SZ times WQ. One last proof for this video. Go ahead, do your statements, reasons, and givens. So from our proof statement, we want to recognize this is just a similar triangle proof. We're going 2 extra steps beyond that. We've got 3 triangles in our picture. Let's see which ones we want to get similar. So start out, we've got AF. AF is a side in only one triangle. It is in triangle AFB. So find the other one that is also a side in that. It's BF. Then your other 2, EF and DF, must make up the other triangle. So we've got BAF and DEF that we're going to work with. We have a parallelogram. This proof is going to be really similar to the one that we just did. We're going to do our parallelogram implies opposite sides parallel. The ones that we want are BA parallel to, and CD extends all the way to E, so we can just call it either CE or you can say CDE. That's fine as well. And that's kind of why they gave us this here, to let us know those are extending all the way through. So next, we'll do our parallel lines. Imply congruent, alternate, interior angles. So from our zigzags, we could have a zigzag here. Just going to call them 1 and 2. We could have a zigzag here along those parallel lines. I'll call them 3 and 4. So we'll have angle 1 congruent to angle 2, and angle 3 congruent to angle 4. Well, that gives us 2 sets of angles in our triangles. We're ready to do our 3 steps to finish off a similar triangle proof. So we have our angle, angle, similarity, postulate. One of our triangles we can call ABF. That's similar to triangle. A was our purple one, that matches with D. B was our blue one, that matches with E. And then you have F. And like I've said for some others, you could have done one set of alternate interior angles congruent and then done one set of vertical angles. That would have been fine as well. Our next reason should be our similar triangles. Implies proportional sides. In your statement, make sure the things you want to multiply are diagonal from each other. So AF and EF I'll put diagonal, and then the others will automatically be diagonal from each other. And to finish off, we have product of means. Equals product of extremes. And our statement is just what we wanted to prove. That's it for this video. Have a great rest of your day.